Hi everybody, this is Algebra 1, Lesson 82, and this lesson covers evaluating functions, domain, and range. Alright, first we have to evaluate this function, and we have already learned that when we have a function, it's going to give us, for every x value, right, we should have a unique y value. So all we have to do, f of x equals x squared plus x minus 10. Find f of 5, that means we just have to plug in 5 wherever we have x. So we've got x squared plus x minus 10, and we're going to plug in 5 wherever we have x. So 5 squared plus 5 minus 10. 5 squared would be 25 plus 5 minus 10. That would be 30. 30 minus 10 equals 20. So f of 5 equals 20. These are pretty easy. Alright, next one. This is h of x equals x squared plus x plus 1. Find h of a squared. Okay, so for this one, we can't really solve it. All we're going to do is we're going to plug in a squared every time we see x. Okay, so I'm going to put in, let's see, a squared, right? So here's my x. I've replaced it with this a squared in parentheses, plus a squared plus 1. Right here, I can add those exponents. No, multiply those exponents because we have a power raised to a power. So that would be a to the 4th plus a squared plus 1. And that is the answer. You can't simplify any more than that. All right, we'll try another one. So all you're doing is plugging in the value that they give you for x. Alright, so this one says f of x equals x squared plus 1. So we've got x squared plus 1. That's our function. And we're supposed to plug in x plus 2. So right here, where we have x, we're going to plug in x plus 2 squared, because our x has to be squared, plus 1. Well, x plus 2 squared means x plus 2 times x plus 2. And we're going to rainbow that and get x squared. And then we would add those, so we would get plus 2x, and then another plus 2x right here. And then 2 times 2 would be 4. So we would get x squared plus 4x plus 4. Alright, so that would be x squared plus 4x plus 4 plus 1. Only like terms we can put together are right here, the 1 and the 4. So we would get x squared plus 4x plus 5. And that is the answer to that one. So sometimes you'll come out with an answer, x equals, and sometimes you will not be able to simplify it completely. Alright, domain. The domain is the set of acceptable x values or the set of inputs. Okay, so domain is talking about inputs. What things can x equal? Okay, so domain is your inputs. Range is the set of resulting y values or the set of outputs. Okay, so you put one number in, that's your domain, the things you can put into your function. Your range are the things that come out of your function, your answers. Okay. If a number is an acceptable replacement for x, we say that the number is a member of the domain of the function. We call the set of all possible outputs of the function the range. So your inputs are your domain, your outputs are your range. In this text, we use only real numbers as replacement values for x, and we accept only values of f of x that are real numbers. We cannot use numbers for x that result in division by 0, or that require us to take the square root of negative numbers, so no negative squares. All right, let's see what some problems that pertain to this look like. If f of x equals 2x, find the domain and range of the function f. Okay, so that means that The domain is going to be anything that we can. Remember, domain is the input values, right? Domain is your input. So what letter or what numbers can X be? Okay. Well, pretty much any real number, right? So if we graph this, right? If we put in for X, see, that would be there. And then we would get, this will be 2 over 1, 2 over 1. So here's the graph of it. Like that. And remember, that line keeps going on forever and ever and ever, right? So our domain of function f equals the set of all real numbers. Remember, it can't be any imaginary numbers like division by 0 or a negative square root. All right, so for the range, so our x value is everything, right, that's going back and forth. So it could be negative numbers all the way that way, positive numbers all the way that way, right? So that's going to be back and forth. Our y value is what comes out. That's going to be our up and down. So this is our independent variable, and then our dependent variable goes up and down. It could be anything up and down, right? Because this line keeps going up, right? So the range of f equals the set of all real numbers. So just the same as the domain. All right, if f of x equals 3, find the domain and the range. It can be applied to any real number, so we could put anything into x. So the domain is set of all real numbers. Okay. The only value the function f ever attains is 3. So if we say that x equals 3, that means no matter what we put into this function, 3 is always going to come out. It's always going to be equal to 3. So if we put 2, we're going to get 3 no matter what, right? Once we put it through that function, it's always going to equal 3. So our range equals 3. Actually, yeah, you put it in the little set signs. So our range is 3, and our domain is all real numbers. The graph of the function f is shown. Determine the domain and range of f. Okay, so remember, your domain is your x value, right? Your input. And your range is going to be your y value, your output. Okay, whatever you put in for x, you're going to get a value of y out. Well, remember, x is what's going back and forth, right? So the lowest number is -2, but it's not -2, it's everything greater than -2. And your highest number right here is 1, 2, 3, +3. Okay, so our domain equals, first we have to say it's going to be real numbers. So x is in the set of real numbers. And then we're going to put a little line. That means such that, right? And this is -2 is less than x, which is greater than or equal to +3. All right, so we just made a conjunction for that. Remember, we've been doing those. So -2 right down here, it can't be equal to -2. It's only everything that is less or greater than -2. So x is greater than -2. And on this side, it can be equal to it because it's filled in. So that's our domain. Our range, remember, that's our y values. Y is up and down. So our highest y value right here is 1, 2, 3. Okay? That's our highest y value. Our highest y value on this side, oh, wait, that's not our highest y value. Our highest y value is up here, which is 1, 2, 3, 4. Okay, and then our lowest is down here, which is 0. That one's 0, 0. That's 2, 3. So there's those points. So our highest is 4 and our lowest is 0. Okay, so our range, it's going to be x is the real numbers such that 0 is less than x less than or equal to, because there's not a dot there, it just goes down, it can be equal to. All right, x, which is less than or equal to 4, because this is filled in, so it could be equal to. I didn't write my little bracket properly. So basically, you just make a conjunction for each of those. Domain is your x, and your range is y. Find the domain of the function f of x equals square root of x minus 5 minus x. So we want to find the set of all acceptable x values for our domain. Okay, so inside this radical box, it cannot be a negative, since the square root of a negative number is not a real number. Okay, so anything that's inside a radical has got to be a positive number. So we know that x has to be greater than 0 to start off with, right? So 5 minus x has to be greater than or equal to 0. It can't be anything, like the square root of that can't be anything less than 0. So we could solve this inequality by saying 5 is greater than or equal to x. And then basically there's our answer. So our domain equals x is the real numbers such that x is, we just flip these around, right? So greater than or equal to 5. Pretty easy. All right, so whenever you have it underneath a radical sign right here, you're just going to set that as being, it can't be any less than 0. So that means that this is greater than or equal to 0. All right, find the domain of the function g of x equals 1 over x. Okay, so we know that we need to find everything that's an acceptable value of x, but x cannot be 0, right? So this one's real easy. It can be any number that's not 0, okay? So, because we can't divide by 0, but we could divide by any other number. So this one's domain equals, x is the real numbers such that x is not equal to 0. And that's how you would answer that one. So anytime you have a fraction one, you're just going to say it's real numbers that are not equal to 0. All right, go ahead and pause the video and work the practice problems. You can look back in the book at how to solve each of these if you get confused. Okay, we'll start with practice A. This is one where you just got to plug that value in. So we're going to take this value right here. Let's see, let me get my pen. We're going to take this value, m squared, and we're going to plug it in each time we have an x. So we've got 2 times x, which is m squared, and that is squared, plus 3 times m squared minus 5. All right, right here we're going to multiply power to a power, so we're going to say 2m to the 4th plus 3m squared minus 5. Let me double check that. Yep, and that's the answer to A. This one, we're just going to plug our value in. Okay, so we've got m plus 2, and we're going to put that anywhere where we see x. So right there. So that would be, instead of x, I'm going to write m plus 2, and that's squared minus 4. So I have to square m plus 2, so m plus 2 times m plus 2. So I'm going to get m squared plus 2m plus another 2m. 2 times 2 is 4. So I've got m squared plus 4m plus 4. Alright, so m squared plus 4m plus 4 is all this, okay, minus 4. Well, those cancel each other off, so our answer is m squared plus 4m. Alright, next one. If f of x equals 3x, find the domain and range of the function f. Okay, so for this one, our domain is going to equal real numbers, of course. Pretty much any real number can be substituted. You can multiply anything times 3, right? So that's going to be, how did they put that? X equals reals. And when they write it in the book, they write it in that weird little R with a double line, which means real numbers. And then our range. And we can multiply anything times 3. That means that we can come up with any answer, right? So that's going to be y equals any real number. So for that one, it's just x equals real numbers and y equals real numbers. All right, on this one, we've got g of x equals 2. Find the domain and the range of the function. Okay, so any real number could go in. 2 is the only thing that's going to come out. So our domain equals x equals the real numbers. And then our range, all right, y or g is always going to equal 2. Okay, so our range is 2. No matter what we put into this function, we're always going to get 2 out of it. All right, the graph of the function f is shown. Determine the domain and range of f. actually going to make this line darker so you guys can see it better. All right, there we go. Okay, so our range is going to be our x values, right? And no, our domain, whoopsie. Domain is going to be our x values. Keep writing the wrong one. Our range is going to be our y values, right? So domain is anything we could put in for x. Y is anything that comes out. X is going across, right? So that would be our independent variable. And then our y is what's up and down. All right, so our domain is going to equal our real numbers such that, all right, so what is the highest and lowest x value? So if we're going across, our lowest x value would be -1, and our highest would be 5. Okay, so it's in between -1 and 5. So that means that -1 is less than, and this is open, so that means it's not equal to, it's just less than x, which is less than or equal to, see how this one's filled in, 5. All right, then we're going to do our range. And this one is going to be our up and down. So our highest point, these are our y numbers. Remember, y is the second number listed on the graph, so right there. Let me use a different color. What do we got? How about green? So that 3 is our highest y value. Oh, that's not set up right, is it? I don't think I graphed it properly. Hang on. Let me check this. I might have made my graph wrong. CE. Bear with me for a second. Domain. Okay. So I did graph that wrong. Let me fix where this dot goes. Okay, this should be on 3, 5. 1, 2, 3, 4, 5. And then that goes there. All right. So I had the numbers right. I just didn't make my graph right. That looks better. Okay. So now we're saying our highest x value is 3, right? And our lowest x value, y values. Oh, that got me all messed up. Okay, we already did x. That's up here. This one's y. Our range is y. Okay, so our highest y, the highest it ever goes, is 3 right here. So we're measuring our up and down. And the lowest point is -1. Okay, and remember this, that we're looking at the second number now. We don't care about this 2 right here because it's in between, right? We just want the lowest point and the highest point, right? And when we were working on the domain, we were worried about back and forth, right? Our x values. Okay, so if our highest point is 3 and our lowest point is -1, that means our range equals the x equals the real numbers, such that our lowest one is -1 is less than or equal to x, right? And then, because x is everything greater than -1 right there, so everything above it. And then less than or equal to 3. Okay, so our lowest point is -1, our highest point is 3. Oops, that's not supposed to be an x in there. That is supposed to be a y, because this was our y. There we go. All right. Next one. Find the domain of the function 3 equals negative x. All right, so we know that that can't equal 0. All right, so we're going to say, and it can't be a negative number. It could be equal to or greater than 0. It can't be anything less than 0. So we're going to say 3 minus x has to be greater or equal to 0. So now we're going to do plus x, and we get 3 is greater than or equal to x. So that means our domain, which is our x value, that one's going to be x equals our reals such that x is less than or equal to 3. All right, and you see how I flip that around? If I put the 3 over on the other side and the x on that side, I just have to flip my sign. X is less than. The chompies are facing towards the 3, so we got to make sure they're still facing towards it over there. All right, hopefully that wasn't too confusing. If you have any questions, don't hesitate to ask. Thanks for watching.